everybody, and welcome to today's webinar, TotalArc Relighter versus Burner Management System. My name is Chris Posey. I'm the marketing manager here at OGI. We're happy to have you on our first webinar of 2021 and another first for today. It's our first time to cover one of our products, the TotalArc, and so we're excited about that. Our presenter today is Jose Pereira. Jose is the Director of Engineering here at OGI. He's been here for about 9 years now, and Jose has very intimate firsthand knowledge of the units that we're going to be looking at today. If you have questions throughout the course of the presentation, you can enter those in the chat box on the right side of your screen at any time. And at the end of our presentation, Jose will go through those and answer those for you. But don't feel like you have to wait until the end of the presentation to put your question out there. So we'll take a few moments at the end of the presentation to answer those. So I think with that, I'll go ahead and turn it over to Jose. So Jose, why don't you take it away for us?
All right. Well, hello, everyone, and thank you for joining us today on this webinar. I'm happy to always, have this kind of relationship with both our reps and our customers. In a way, our approach is that the better that our customers and reps understand our products, the better support we'll be able to provide to them. On this particular webinar, we're going to be talking specifically about the differences between the TotalArc Relighter and the TotalArc burner management system. I am not going to provide a lot of history about the TotalArc product family. I will just briefly say that the TotalArc, it's a product line that was internally developed at OGI Process Equipment, and it was born just by the necessity of having a reliable relighting system. In the past, we used many other manufacturers' products, and we had many problems from reliability to supply to technical support. So back in 2012, we decided that enough is enough. So what better than being able to control your product line and your controls that you put on your equipment so we can provide our customer with the best possible support. So with that, we're just going to go into what defines a relighter and what defines a burner management system. All right, the TotalArc Relighter in specific monitors the presence of a flame, and in the event that a flame is no longer present, then it will just relight it. It doesn't do any more controls than that, and it is installed with a pneumatic control system. On the other hand, a burner management system monitors a heat request that could be either a pneumatic temperature controller or an electronic temperature controller via a thermocouple. After it receives a run signal or a heat request, then it will initiate the startup of the process, including purge cycles, and it will actually light off the pilot and consequently the main gas valve. With that, we're going to go in just a little bit deeper on the TotalArc Relighter. So the TotalArc Relighter, our main approach to the design of this system was to maintain reliability and simplicity. We understand that a lot of the times there are many obstacles in the field that will prevent a heater from running, and that was one thing we didn't want to do. We didn't want to add another layer of complexity for those customers that like to maintain that simple approach. Even with the simplicity of it, we still include a remote monitoring capabilities, and truly this is just a dry contact set that in the event of a complete flame failure, then it would actually send a signal out indicating that your heater is down. Because the TotalArc Relighter works with a pneumatic flame safeguard, it only allows for one relight attempt. We ignite the spark for during a time of 15 seconds. If during that time you don't have a flame, there might be other issues that you need to check. We focus our prospects for the TotalArc Relighter into upgrading basic, even more simple systems that only have a push button ignition system, and the replacement of other manufacturers' relighting systems. Some of the features that the TotalArc Relighter has is, of course, as we mentioned before, it works in conjunction with a pneumatic flame safeguard. The power options that we offer on the TotalArc Relighter, it's 120 volts, and that comes with a battery backup to maintain the operation of the TotalArc Relighter even when power goes out. We also have an option for, it's a solar system that has a 12-volt battery inside of it, and it will maintain the operation of your TotalArc Relighter for a period of 7 days, and that is without solar power. So those areas that get quite a bit of snow coverage, we almost almost request that once a week that to go by and make sure that the solar panel is still exposed. And additionally, we also have another TotalArc Relighter that has a power option of 12 to 24 volts DC. This was created based on the request of a few customers that actually have power on site. And in some of these facilities, they have 24 volts DC that already comes from a system that is under battery power. Additionally, the TotalArc is UL listed for a Class 1 Div 2 under UL. And the most important thing, it's an unintrusive design. That means that if for any reason your heater goes down, if for any reason your TotalArc goes down, either for, discharged battery or for a failure of a component, then you can still get your heater to run under a manual light off condition. The TotalArc will not interrupt the operation of your heater, even if the TotalArc is completely turned off. Some of the benefits you have with using the TotalArc Relighter is that it utilizes the same process gas that your heater uses. It's quite versatile because you can install it in a couple of different configurations to operate your heater. And like we said before, it is rated for Class 1 Div 2, even if you mount it close to the heater. I know we know some providers, they're not listed for Class 1 Div 2, and that requires that their controls has to be installed far away from the heater on a remote enclosure. And as mentioned before, even if you lose power to your unit, the TotalArc will allow the operation of your heater under manual conditions. And then the remote indication of a heater shutdown condition, it is provided via a dry contact relay. Now here we're going to talk a little bit about the operation of the TotalArc Relighter. And I'm hoping that you guys can see my mouse. So this is just a very basic PNID, and of course we have cut off a lot of the components we didn't need just for clarity. But we will start our review of this PNID from the numeric control side. So once you have been able to confirm that all your safeties are okay, that means we're going to have pressure at this point of the FSG 200. The FSG 200 is that pneumatic flame safeguard that we discussed earlier. The operation of this flame safeguard is just as it could be on one of these old water heaters that we have in our house, right? We have a plunger that you have to press and hold. And as you press and hold the plunger of the pneumatic flame safeguard, you will press the push button on the TotalArc, which will start the ignition process of the pilot. Once the pilot is lit, it'll take a few seconds for this thermocouple to warm up and to hold in place. as that thermocouple is holding the pilot flame on, then it will provide gas to the pneumatic safety control loop, which will then provide gas to the safety shutdown valve. Now, you guys will see that coming out of the TotalArc, there is a SVP 101. So this valve, it's is controlled by the TotalArc Relighter, and it's the same power. And what it does, we have included we call it an augmented safety to the flame safeguard, that when we are in the process of starting up a TotalArc, or while it is in the process of sparking the pilot, it will actually shut off the gas supply to the temperature control valve. What we're trying to do with that is we're trying to prevent the entry of natural gas into the fire tube. Once the pilot is confirmed to be on, then this valve will be released and will allow this valve to operate as normal. Now we go into the TotalArc burner management system. So the TotalArc Relighter was a great first step for OGI process equipment. And then we decided that, continuing to use the same platform and design as we did on the TotalArc Relighter, we worked on the burner management system. Under the burner management system, we have two options on which we can operate the TotalArc BMS. One is a pneumatic option, and the other one is an electronic option. We offer the same kind of remote monitoring capabilities with a dry contact relay and one relight attempt in the case of a flame failure. These controls are actually oriented towards smaller heaters that have such a small thermal mass capacity that even keeping the pilot on could cause an over temperature condition of the high bath temperature shutdown. Additionally, another area or another target of these controllers are areas that require a much tighter temperature control. As we know, pneumatic controllers do have quite a bit of a wide deadband on controls. And so with the TotalArc BMS, an electronic version of it, we can actually use a thermocouple and we can specify, down to 1/4 of a degree, what is your set point that you want to control these heaters. Some of the options and features we have is, as we discussed, pneumatic versus electronic control. Power options are the same as we have on the TotalArc Relighter, 120 volts, solar with battery backup, and 24 volts DC. It is also listed to operate in a hazardous area location under Class 1 DIV2, and also being able to install it on the heater. You do not have to move it away from the heater to get that classification. Again, we use the same process gas that we operate the heater with. This system, as well as the TotalArc Relighter, they both use a single rod ignition system. So that means that we use the ignition rod for creation of the spark plus monitoring of the flame signal. And the TotalArc BMS can be configured as a thermostatic pilot or an intermittent pilot. So given that we can operate this unit in two different ways, we're going to discuss on the pneumatic system, right? We're going to go for the most simple approach to this TotalArc. And so on the thermostatic pilot, when your safeties are on, your pilot gas is going to be on at all times. And then your temperature control is actually controlled by a pneumatic controller. Pilot is always on as long as your safeties are okay. This would be more oriented to units that have more thermal mass on their bath. The intermittent pilot, on the other hand, it can be configured both ways on the pneumatic and the electronic method. And so in this particular case, you only run your pilot valve when there is a heat request. meaning if both your bath and process are at temperature, you don't need to have the pilot on. So at that stage, you can turn off the pilot and you don't have to maintain that pilot on at all times. That is, yeah, that's all we have there. So what we're going to do now, we're going to just do a quick brief evaluation of this PNID for this thermostatic pilot operation. So again, here is a very reduced version of the PNID. And so here's where we get the supply gas of our controls. So in this particular condition, we will have to go through the high bath temperature shutdown to be able to get pressure to this section here, which is the pressure switch, the pneumatic pressure switch that the TotalArc burner management system uses. Once the high bath temperature shutdown is below the set point, in this particular case was set at 190 degrees, we will register a pressure signal here, which will send the signal to the TotalArc BMS, telling him to start the pilot. At that stage, the TotalArc will open the pilot valve and actually create an ignition on the at the pilot nozzle, and it will light up the pilot. Once we have gone through the pre-purge and flame proving periods, then the TotalArc BMS will open the main gas valve. That period of time is 10 seconds. So once we have confirmed that the pilot flame has been on and steady for 10 seconds and we have a good quality flame on the pilot, then it will request to open the main gas valve on the for the main burner. And at that time, that gas valve will provide gas to the process controller. In many cases, there will also be a bath temperature controller in line with this controller. And after that, then it will provide gas to both the temperature control valve and the safety shutdown valve. So this design or this configuration is focused more for larger heaters that have more bath thermal mass, and they have enough capacity to allow the pilot to run on without causing over temperature condition. One of the drawbacks of that is that at all times you are going to maintain the pilot valve and the main gas valve on at all times, and that of course draws power out of the system. Especially there shouldn't be a major concern about this, except but for systems that are remotely located and run on solar power. As we go into the intermittent pilot, then it's a similar setup, same PNID as we had before, with the difference that this time we actually place the pressure switch after the process temperature controller. So we get our supply gas in the same location. If we make our bath high temperature shutdown and our process controller requests heat, then it will provide pressure to pressure switch 103, which will trigger a call for heat on the TotalArc BMS. Once again, TotalArc BMS will create a signal to open the gas valve along with the ignition transformer to light up the pilot. And after the proven times of the pilot flame, then we'll go ahead and open the main gas valve. So at this time, you're only going to run your valves at the time that you actually need heat. If your heater is in standby and your process conditions have been reduced and you're not drawing that much heat out of the bath, then your system can just be waiting for that instead of keeping the pilot on at all times. Now, this design is focused primarily on smaller heaters that, like I said before, even the pilot running will cause an over temperature condition. Additionally to that, we have the electronic controller. If you notice, the main difference you will see on this one is that it's missing the pneumatic controller here to the side of the enclosure. So what we do in this kind of setup, we actually read our signals from the stack, the bath, and the process coil via a thermocouple. With that, we enter our set points on an electronic module, and this data entry is actually done via Bluetooth through an application that can be obtained for both Android and Apple systems. And so it comes with a module you plug in into these temperature modules, and it will allow you to adjust your set points. Operation is the same as we discussed previously, with the benefit that being that you are going to be working on an electronic system, you have a much tighter control on regards of your set points and deadbands for the operation of the unit. With all of that, both of these systems, both the Relighter and the BMS, are available on a polycarbonate enclosure and on a stainless steel enclosure. This will be driven mainly by customer requirements they might have for specific locations. In general terms, that's everything we have for the TotalArc family overall. Now, we also want to comment that OGI Process Equipment has an internal department. We call it OGI Process Controls, on which we manufacture custom control systems. We do not rely just on basic systems like the TotalArc systems, but we also have PLC control systems that utilize other controllers like Honeywell 7800 series controllers. From going along with the certifications we have in the TotalArc, OGI is a UL listed panel shop for both US and Canada. We have our certifications for all the hazardous locations, even with non-incentive panels. And some of the manufacturers that we use as a standard basis are Allen Bradley, GE, and many more. But in general terms, these are kind of the top that we always use more commonly. We just do not just build them, but we actually do the full design, assembly, fabrication, and programming of the control systems. So, we're kind of a one-stop shop where we can provide any necessity, either from, very simple junction boxes to complex PLC control systems. And like I said before, even with the benefit of being able to do the programming for you. In general terms, that is everything that I have. If you guys have any questions, I will be happy to answer them next.
Okay, thank you, Jose. That was great. As Jose mentioned, if you have any questions, please go ahead and type those into the chat screen at the right side of the console. We'll give that a minute or two while we're doing that. Let me tell you about our next webinar. The next OGI webinar is going to be the benefits of quick water multi-tower in the food and beverage industry. And that one will be presented in March, on March 24th at 10 o'clock in the morning, just like this one. We'll have registration information out for that one soon after we conclude today's webinar. If you're interested in listening to today's webinar again, if you missed some details or you want to share with colleagues or anything like that, we will be making today's webinar available to you on demand, and I will send an email out that will contain the link to that today or tomorrow, so you can keep an eye out for that if you're interested in that. I'm not seeing any questions over in the chat console, so we will we'll go ahead and conclude this session. And thanks to Jose again for presenting today. Thanks to all of you for coming out today, joining us on this webinar. Do be sure to follow OGI on Facebook, LinkedIn, Instagram, and Twitter. You can see news not only about these webinars, but everything else that's going on here at OGI at those channels. And so with that, I think we will conclude. Again, thank you for joining us today, and we hope to see you again soon.